Gildan Media, a division of Recorded Books, presents Artificial Intelligence for Dummies by John Mueller and Luca Massaron. Narrated by Chris Sorensen. Introduction. You can hardly avoid encountering mentions of AI today. You see AI in the movies, in books, in the news, and online. AI is part of robots, self-driving cars, drones, medical systems, online shopping sites, and all sorts of other technologies that affect your daily life in so many ways. Many pundits are burying you in information and disinformation about AI too. Some see AI as cute and fuzzy. Others see it as a potential mass murderer of the human race. The problem with being so loaded down with information in so many ways is that you struggle to separate what's real from what is simply the product of an overactive imagination. Much of the hype about AI originates from the excessive and unrealistic expectations of scientists, entrepreneurs, and business persons. Artificial Intelligence for Dummies is the book you need if you feel as if you really don't know anything about a technology that purports to be an essential element of your life. Using various media as a starting point, you might notice that most of the useful technologies are almost boring. Certainly no one gushes over them. AI is like that, so ubiquitous as to be humdrum. You're even using AI in some way today. In fact, you probably rely on AI in many different ways. You just don't notice it because it's so mundane. Artificial Intelligence for Dummies makes you aware of these very real and essential uses of AI. A smart thermostat for your home may not sound very exciting, but it's an incredibly practical use for a technology that has some people running for the hills in terror. Of course, Artificial Intelligence for Dummies also covers the really cool uses for AI. For example, you may not know there is a medical monitoring device that can actually predict when you might have a heart problem, but such a device exists. AI powers drones, drives cars, and makes all sorts of robots possible. You see AI used today in all sorts of space applications, and AI figures prominently in all the space adventures humans will have tomorrow. In contrast to many books on the topic, Artificial Intelligence for Dummies also tells you the truth about where and how AI can't work. In fact, AI will never be able to engage in certain essential activities and tasks, and won't be able to do other ones until far into the future. Some people try to tell you that these activities are possible for AI, but Artificial Intelligence for Dummies tells you why they can't work, clearing away all the hype that has kept you in the dark about AI. One takeaway from this book is that humans will always be important. In fact, if anything, AI makes humans even more important because AI helps humans excel in ways that you frankly might not be able to imagine. About this book. Artificial Intelligence for Dummies starts by helping you understand AI, especially what AI needs to work and why it has failed in the past. You also discover the basis for some of the issues with AI today, and how those issues might prove to be nearly impossible to solve in some cases. Of course, along with the issues, you also discover the fixes for some problems and consider where scientists are taking AI in search of answers. For a technology to survive, it must have a group of solid applications that actually work. It also must provide a payback to investors with the foresight to invest in the technology. In the past, AI failed to achieve critical success because it lacked some of these features. AI also suffered from being ahead of its time. True AI needed to wait for the current hardware to actually succeed. Today, you can find AI used in various computer applications and to automate processes. It's also relied on heavily in the medical field and to help improve human interaction. AI is also related to data analysis, machine learning, and deep learning. Sometimes these terms can prove confusing, so one of the reasons to listen to Artificial Intelligence for Dummies is to discover how these technologies interconnect. AI has a truly bright future today because it has become an essential technology. This book also discussed the paths that AI is likely to follow in the future. The various trends discussed in this book are based on what people are actually trying to do now. The new technology hasn't succeeded yet, but because people are working on it, it does have a good chance of success at some point. Icons used in this book. As you listen to this book, you'll hear icons that indicate material of interest, or not, as the case may be. This section briefly describes each icon in this book. Tip. Tips are nice because they help you save time or perform some task without a lot of extra work. The tips in this book are time-saving techniques or pointers to resources that you should try in order to get the maximum benefit from learning about AI. Warning. We don't want to sound like angry parents or some kind of maniacs, but you should avoid doing anything marked with a warning icon. Otherwise, you could find that you engage in the sort of disinformation that has people terrified of AI today. Technical stuff. Whenever you hear this icon, think advanced tip or technique. You might find these tidbits of useful information just too boring for words, or they could contain the solution you need to create or use an AI solution. Skip these bits of information whenever you like. Remember, if you don't get anything else out of a particular chapter or section, remember the material marked by this icon. This text usually contains an essential process or bit of information that you must know to interact with AI successfully. Beyond the book. This book isn't the end of your AI discovery experience. It's really just the beginning. We provide online content to make this book more flexible and better able to meet your needs. That way, as John receives email from you, we can address questions and tell you how updates to AI or its associated technologies affect book content. In fact, you'll gain access to all these cool additions. Cheat sheet. You remember using crib notes in school to make a better mark on a test, don't you? You do? Well, a cheat sheet is sort of like that. It provides you with some special notes about tasks that you can do with AI that not everyone else knows. You can find the cheat sheet for this book by going to Dummies.com and searching for Artificial Intelligence for Dummies cheat sheet. The cheat sheet contains really neat information, such as the meaning of all those strange acronyms and abbreviations associated with AI, machine learning, and deep learning. Updates. Sometimes changes happen. For example, we might not have seen an upcoming change when we looked into our crystal balls during the writing of this book. In the past, that simply meant that the book would become outdated and less useful. But you can now find updates to the book by going to Dummies.com and searching this book's title. In addition to these updates, check out the blog posts with answers to readers' questions, and for demonstrations of useful book-related techniques at blog.john.muellerbooks.com. Where to go from here? It's time to start discovering AI and see what it can do for you. If you don't know anything about AI, start with Chapter 1. You may not want to listen to every chapter in the book, but starting with Chapter 1 helps you understand AI basics that you need when working through other places in the book. If your main goal in listening to this book is to build knowledge where AI is used today, start with Chapter 5. The materials in Part 2 help you see where AI is used today. Listeners who have a bit more advanced knowledge of AI can start with Chapter 9. Part 3 of this book contains the most advanced material that you'll encounter. If you don't want to know how AI works at a low level, not as a developer but simply as anyone interested in AI, you might decide to skip this part of the book. Okay. So you want to know the super fantastic ways in which people are either using AI today or will use AI in the future. If that's the case, start with Chapter 12. All of Parts 4 and 5 discuss the incredible ways in which AI is used without forcing you to deal with piles of hype as a result. The information in Part 4 focuses on hardware that relies on AI, and the material in Part 5 focuses on more futuristic uses of AI. 1. Introducing AI. Chapter 1. Introducing AI. Artificial intelligence, AI, has had several false starts and stops over the years, partly because people don't really understand what AI is all about or even what it should accomplish. A major part of the problem is that movies, television shows, and books have all conspired to give false hopes as to what AI will accomplish. In addition, the human tendency to anthropomorphize, give human characteristics to technology, makes it seem as if AI must do more than it can hope to accomplish. So, the best way to start this book is to define what AI actually is, what it isn't, and how it connects to computers today. Remember, of course, the basis for what you expect from AI is a combination of how you define AI, the technology you have for implementing AI, and the goals you have for AI. Consequently, everyone sees AI differently. This book takes a middle-of-the-road approach by viewing AI from as many different perspectives as possible. It doesn't buy into the hype offered by proponents, nor does it indulge in the negativity espoused by detractors, so that you get the best possible view of AI as a technology. As a result, you may find that you have somewhat different expectations than those you encounter in this book, which is fine. But it's essential to consider what the technology can actually do for you rather than expect something it can't. Defining the term AI. Before you can use a term in any meaningful and useful way, you must have a definition for it. After all, if nobody agrees on a meaning, the term has none. It's just a collection of characters. Defining the idiom, a term whose meaning isn't clear from the meanings of its constituent elements, is especially important with technical terms that have received more than a little press coverage at various times in various ways. Remember, saying that AI is an artificial intelligence doesn't really tell you anything meaningful, which is why there are so many discussions and disagreements over this term. Yes, you can argue that what occurs is artificial, not having come from a natural source. However, the intelligence part is, at best, ambiguous. Even if you don't necessarily agree with the definition of AI as used in the sections that follow, this book uses AI according to that definition, and knowing it will help you follow the rest of the text more easily. Discerning intelligence. People define intelligence in many different ways. However, you can say that intelligence involves certain mental activities composed of the following activities: learning, having the ability to obtain and process new information; reasoning, being able to manipulate information in various ways; understanding, considering the result of information manipulation; grasping truths, determining the validity of the manipulated information, seeing relationships, divining how validated data interacts with other data, considering meanings, applying truths to particular situations in a manner consistent with their relationship, separating fact from belief, determining whether the data is adequately supported by provable sources that can be demonstrated to be consistently valid. The list could easily get quite long, but even this list is relatively prone to interpretation by anyone who accepts it as viable. As you can see from the list, however, intelligence often follows a process that a computer system can mimic as part of a simulation. 1. Set a goal based on needs or wants. 2. Assess the value of any currently known information in support of the goal. 3. Gather additional information that could support the goal. 4. Manipulate the data such that it achieves a form consistent with existing information. 5. Define the relationships and truth values between existing and new information. 6. Determine whether the goal is achieved. 7. Modify the goal in light of the new data and its effect on the probability of success. 8. Repeat steps 2 through 7 as needed until the goal is achieved, found true, or the possibilities for achieving it are exhausted, found false. Remember, even though you can create algorithms and provide access to data in support of this process within a computer's capability to achieve intelligence is severely limited. For example, a computer is incapable of understanding anything because it relies on machine processes to manipulate data using pure math in a strictly mechanical fashion. Likewise, computers can't easily separate truth from mistruth, as described in Chapter 2. In fact, no computer can fully implement any of the mental activities described in the list that describes intelligence. As part of deciding what intelligence actually involves, categorizing intelligence is also helpful. Humans don't use just one type of intelligence, but rather rely on multiple intelligences to perform tasks. Howard Gardner of Harvard has defined a number of these types of intelligence, and knowing them helps you to relate them to the kinds of tasks that a computer can simulate as intelligence. Discovering 4 ways to define AI. As described in the previous section, the first concept that's important to understand is that AI doesn't really have anything to do with human intelligence. Yes, some AI is modeled to simulate human intelligence, but that's what it is, a simulation. When thinking about AI, notice an interplay between goal-seeking, data processing used to achieve that goal, and data acquisition used to better understand the goal. AI relies on algorithms to achieve a result that may or may not have anything to do with human goals or methods of achieving those goals. With this in mind, you can categorize AI in 4 ways. Acting humanly. When a computer acts like a human, it best reflects the Turing test, in which the computer succeeds when differentiation between the computer and a human isn't possible. This category also reflects what the media would have you believe AI is all about. You see it employed for technologies such as natural language processing, knowledge representation, automated reasoning, and machine learning, all 4 of which must be present to pass the test. The original Turing test didn't include any physical contact. The newer total Turing test does include physical contact in the form of perceptual ability interrogation, which means that the computer must also employ both computer vision and robotics to succeed. Modern techniques include the idea of achieving the goal rather than mimicking humans completely. For example, the Wright brothers didn't succeed in creating an airplane by precisely copying the flight of birds. Rather, the birds provided ideas that led to aerodynamics that eventually led to human flight. The goal is to fly. Both birds and humans achieve this goal, but they use different approaches. Thinking humanly. When a computer thinks as a human, it performs tasks that require intelligence, as contrasted with rote procedures from a human to succeed, such as driving a car. To determine whether a program thinks like a human, you must have some method of determining how humans think, which the cognitive modeling approach defines. This model relies on 3 techniques. Introspection. Detecting and documenting the techniques used to achieve goals by monitoring one's own thought processes. Psychological testing. Observing a person's behavior and adding it to a database of similar behaviors from other persons given a similar set of circumstances, goals, resources, and environmental conditions, among other things. Brain imaging. Monitoring brain activity directly through various mechanical means, such as computerized axial tomography, CAT, positron emission tomography, PET, magnetic resonance imaging, MRI, and magnetoencephalography, MEG. After creating a model, you can write a program that simulates the model. Given the amount of variability among human thought processes and the difficulty of accurately representing these thought processes as part of a program, the results are experimental at best. This category of thinking humanly is often used in psychology and other fields in which modeling the human thought process to create realistic simulations is essential. Thinking rationally. Studying how humans think using some standard enables the creation of guidelines that describe typical human behaviors. A person is considered rational when following these behaviors within certain levels of deviation. A computer that thinks rationally relies on the recorded behaviors to create a guide as to how to interact with an environment based on the data at hand. The goal of this approach is to solve problems logically when possible. In many cases, this approach would enable the creation of a baseline technique for solving a problem, which would then be modified to actually solve the problem. In other words, the solving of a problem in principle is often different from solving it in practice, but you still need a starting point. Acting rationally. Studying how humans act in given situations under specific constraints enables you to determine which techniques are both efficient and effective. A computer that acts rationally relies on the recorded actions to interact with an environment based on conditions, environmental factors, and existing data. As with rational thought, rational acts depend on a solution in principle which may not prove useful in practice. However, rational acts do provide a baseline upon which a computer can begin negotiating the successful completion of a goal. Human versus rational processes. Human processes differ from rational processes in their outcome. A process is rational if it always does the right thing based on the current information, given an ideal performance measure. In short, rational processes go by the book and assume that the book is actually correct. Human processes involve instinct, intuition, and other variables that don't necessarily reflect the book and may not even consider the existing data. As an example, the rational way to drive a car is to always follow the laws. However, traffic isn't rational. If you follow the laws precisely, you end up stuck somewhere because other drivers aren't following the laws precisely. To be successful, a self-driving car must therefore act humanly rather than rationally. The categories used to define AI offer a way to consider various uses for or ways to apply AI. Some of the systems used to classify AI by type are arbitrary and not distinct. For example, some groups view AI as either strong, generalized intelligence that can adapt to a variety of situations, or weak, specific intelligence designed to perform a particular task well. The problem with strong AI is that it doesn't perform any task well, while weak AI is too specific to perform tasks independently. Even so, just two type classifications won't do the job even in a general sense. The four classification types promoted by Arr and Hintze form a better basis for understanding AI. Reactive machines. The machines you see beating humans at chess or playing on game shows are examples of reactive machines. A reactive machine has no memory or experience upon which to base a decision. Instead, it relies on pure computational power and smart algorithms to recreate every decision every time. This is an example of a weak AI used for a specific purpose. Limited memory. A self-driving car or autonomous robot can't afford the time to make every decision from scratch. These machines rely on a small amount of memory to provide experiential knowledge of various situations. When the machine sees the same situation, it can rely on experience to reduce reaction time and to provide more resources for making new decisions that haven't yet been made. This is an example of the current level of strong AI. Theory of mind. A machine that can assess both its required goals and the potential goals of other entities in the same environment has a kind of understanding that is feasible to some extent today, but not in any commercial form. However, for self-driving cars to become truly autonomous, this level of AI must be fully developed. A self-driving car would not only need to know that it must go from one point to another, but also intuit the potentially conflicting goals of drivers around it and react accordingly. Self-awareness. This is the sort of AI that you see in movies. However, it requires technologies that aren't even remotely possible now because such a machine would have a sense of both self and consciousness. In addition, instead of merely intuiting the goals of others based on environment and other entity reactions, this type of machine would be able to infer the intent of others based on experiential knowledge. Understanding the history of AI. The previous sections of this chapter help you understand intelligence from the human perspective and see how modern computers are woefully inadequate for simulating such intelligence, much less actually becoming intelligent themselves. However, the desire to create intelligent machines, or in ancient times, idols, is as old as humans. The desire not to be alone in the universe, to have something with which to communicate without the inconsistencies of other humans, is a strong one. Of course, a single book can't contemplate all of human history, so the following sections provide a brief, pertinent overview of the history of modern AI attempts. Starting with symbolic logic at Dartmouth. The earliest computers were just that, computing devices. They mimicked the human ability to manipulate symbols in order to perform basic math tasks such as addition. Logical reasoning later added the capability to perform mathematical reasoning through comparisons, such as determining whether one value is greater than another value.
Sample complete. Ready to continue?